In this video, we're going to take a look at the quotient rule of exponents. The quotient rule says that if we are dividing two bases that match, how will we simplify the exponents? Let's take a look at what we have with a to the fifth over a squared. A to the fifth means we have 5a's multiplied in the numerator, while a squared says we have 2a's multiplied in the denominator. When reducing fractions, if we have a matching factor in both the numerator and denominator, we can divide them out. Notice we divide out 2 of the a's in both top and bottom, leaving just 3a's, or a cubed, for our final answer. Notice the a squared in the denominator told us how many a's were being divided out. To solve this problem even quicker, we could have just taken the exponents 5 and 2 and subtracted those exponents to know how many are left once we divide out or reduce the fraction. This idea of subtracting the exponents when two bases are divided is the quotient rule of exponents. We can use it to simplify problems like that on the bottom left. Here, we have 7 to the 13th over 7 to the 5th. Because the base of 7 matches, we keep the base and subtract the exponents. 13 minus 5 is 8, and we end up with 7 to the 8th for our simplified solution. On the right is a slightly more involved problem, 5a cubed b to the 5th c squared over 2a b cubed c. The 5 over 2 part can't reduce at all as a fraction, so we'll keep it as 5/2. However, when we get to the a's, we've got exponents that we can subtract. A cubed and a to the first. We see one of the a's is dividing out, and when we subtract the exponents 3 minus 1, we get a squared remaining. Similarly, on the b's, b to the 5th, divide out b cubed, and we're left with b squared, because 5 minus 3 is 2. Again, c squared, and we divide out 1c. If there's no exponent written, we assume there's a 1. We're left with c to the first. And this becomes our final solution, 5/2 a squared b squared c. This is the quotient rule of exponents. If we've got the same base being divided, we simply have to subtract the exponents.